Okay, so welcome to those of you who are already here. Feel free to ask me any general questions about how this class is going to go. If you would like to just ask in the chat, I think there is going to be quite a big group today. It's a trial session, so if everyone starts talking, it will go quite haywire, right? So just if you have anything you want to clarify, just about how the class is going to go, ask in the chat. Obviously, the main purpose of this session is to go through the questions, but as the first session, we will also do a little bit of introduction of what's going on, what to expect, so that you can just decide for yourself whether you think it is a good idea for you to be in this class for subsequent weeks. The session is recorded, as you can tell. We will upload the recording. We will send out the link to the recording for those of you who are currently students with me. For those of you who, let's say, are not, but you have been invited, then we will also probably upload this onto my YouTube channel at some time in the next few days. So you can also, if you missed anything, find it there. So don't worry too much about copying down stuff. Don't worry too much about like, let's say if you want to say, wait, I haven't finished copying, I will probably tell you for today, sorry, we are just going to move on. But you can refer to the solution to be sent out, annotation to be sent out, the whole recording will be available, right? So there is basically nothing that you're going to miss. Yes, so this is meant to be a session that's only Zoom. It is a Zoom-only session. It is sort of in a different mode from our usual classes, which are usually hybrid. This is Zoom only because of a few reasons. One is that it's Wednesday night. Even for my usual 7:30 p.m. classes on weekdays that are hybrid, hardly anyone can come. So I might as well make it Zoom just to make all our life easier. Secondly is that the problem sets will be uploaded week by week. Okay, so this class is meant to be actually inverted from the usual lessons. You will be usually doing the questions before the lesson. And then during the lesson, we are not going to spend all the time, let's say, saying, okay, I'll give you 10 minutes to try the questions. No, we will just spend the time talking about the questions as well as various strategies, as well as various mistakes some of you have made, as well as various places where you got stuck. So if you are in this class, that means that you will have weekly homework. These are the weekly homeworks, and it will be 6 short questions, 4 proving questions. The homework, you don't need to submit it, but except for the last lesson of each month, so just once a month as a checkpoint, I will request that you submit the solutions. Okay, so that is not going to be something where you are expected to be able to solve all of them. If you have seen problems, you will already have some sense of this, but to make it very explicit, because some of you here are Sec 1 students, and some of you here are JC students. There's a whole range. And so if you are the Sec 1 student, I do not want to frighten you. This class will cover questions ranging from SMO Junior to SMO Open, which means that some of it is going to be like, I've never heard of that before. That is to be expected. Conversely, if let's say you are a JC student, you will have some of it that is going to be like, hey, that's quite easy. And if you find that it is quite easy for 1 or 2 questions, that is not representative of the difficulty of the whole class also. This is meant to be wide-ranging. In some sense, I say that it ranges from SMO Junior to SMO Open difficulty, but the SMO Open ranges from Junior to Open difficulty. There are, let's say, every year in the SMO Open, round 1, about 5 questions that could also appear in the SMO Junior and another 10 questions that could also appear in the SMO Senior. So in a sense, Junior to Open difficulty also means Open difficulty. That's also true for round 2, right? The Open round 2 last year had one super easy question, which was actually in my junior mock paper. So, who's to say what's a junior to open difficulty? I'm just trying to say it is wide ranging, so you expect to see some of it that feels much easier and some of it that feels much harder. And it is therefore depending on your level, whether you feel that it is too easy, too hard, or just right. I guess when is this class going to be reasonable is that you should be able to solve most of the junior round one at least and have some idea of how proofs work. If you, let's say, look at the junior round one and say, I cannot solve anything, you will see in the next 1 hour, 45 minutes that everything is going to be confusing. Conversely, if let's say that you are able to already solve more than half of the senior and open round two questions, which is basically senior to national team standard for 50% of SMO senior, and it's definitely national team standard for 50% of the open round two. If you can solve more than 50% of the open round two, means you're basically a national team standard. I can't pitch this class at national team standard. It's going to frighten everyone off. So this class is not that hard, and you'll probably find it a bit easier. But hey, if you're here for the trial session, you can just see how it looks like. This one more thing, this changes every year. So if you were here last year, you will see that these are not the same problems. I keep on setting or sourcing new questions. It's a mixture of questions from me, from random competitions around the world, as well as modified SMO questions. I change them every time. So you should find that even if you were here last year, there are still new problems. There are still interesting things to talk about. Okay, so if you have any questions about, like, let's say, the logistics of the class, feel free to just type in the chat, and I will try to answer you either verbally, or if your question is very specific to you, then I will try to respond via private message in the Zoom chat. For everyone else, welcome. To those of you who are just coming in, we haven't started on the problems proper, but we are now about to do so. Okay, so I hope that you all have a copy of the problems. I will send out a PDF one more time in the Zoom chat, just in case anyone has not received it. So your parents told you, oh, you can join this free session, but then you have no idea what we're doing. Then just send it out in the Zoom chat. You can download it. You can print it out if you want. You can just use your PLDs if you want to go through the questions, up to you. Our lessons are mostly going to be, for this class, going through the questions and also answering any questions that you may have had after trying the problems, like I got stuck here, I got stuck there, how will I think of this? Or if you submit to me your solutions and I realize that many of you made the same mistake, I will address that. Today I cannot do that because this was a relatively late invite. So it is a relatively late invite. Most of you will not have tried all the questions too extensively. So, we're going to just get started with the problems. Some of you mentioned audio issues. Can you hear? Anyone else? I can't ask those who cannot hear me to message in the chat, right? So if you can hear me, just let me know via whatever means are convenient. If you cannot hear me, you would not hear this message. Okay, good. So I think there are enough indications that it is fine. So great, we shall get started. The questions here are not SMO problems. They do not need to have integer answers, as I'm sure you can tell. Good. Okay, question one. Let fx equals to pi to the x plus pi to the negative x over pi to the x minus pi to the negative x, given that a is a real number satisfying f of a equals to 2, find f of 2a. Right? So it basically literally means that this is equal to 2. and you want this. Okay, what's the first thing you want to do when you see this big mess?
Make the first equation pi to the a equal plus pi to the negative a equals to 2 times pi a minus pi to the negative a.
Okay, so you basically mean multiply over to the other side. Yes, so that works perfectly fine. When you are looking at, let's say, something of this sort, you should kind of realize that it is not as bad as it looks. I think for convenience though, yes, as some of you have suggested, we can do a substitution first of y equals to pi to the a so that things are not so ugly. It is never really harmful to do a substitution. Okay, and so what Zheng Xiao has suggested is just multiply over. We can multiply over and so you will end up with y squared equals to 3. And that's good enough, right? Because this is basically just that. So answer is 5/4. Now, depending on how much Olympiad experience you have and what level you're in, of course, this question may either be very easy or just right. But I would say that for those of you who are more experienced, it is still useful once in a while to have some easier questions, right? Because we tend to overthink after we have spent too much time doing hard questions. That means that, for example, you will say that, okay, I'm going to try to square both sides, and then, well, I mean, good things do happen if you square both sides, but it is not going to resolve that quickly either. Right? So with more experience also comes the pitfall of sometimes we just have done way too many questions until we get very stubbornly set into I can only solve the questions this way. So one of the features of this class is that there will be easy questions. In easy, it means these kinds of easy questions, so that you will not forget how to do these kinds of questions, because even the SMO Open still has a few questions like this every time. Okay, number 2. Let A and B be digits. A is non-zero. What is the largest integer that is guaranteed to be a factor of this 8-digit number ABBA ABBA? What is the nice thing about ABBA ABBA? Yeah, it repeats, yes. So if it repeats, then what does that mean? You can factor it, yes. So, I mean, of course, you can factor it in a bunch of cases differently, because the question is literally asking you what is guaranteed to be a factor. But the most obvious immediate factorization is that it's ABBA times 10,000 plus one more copy of ABBA, so it's 10,000 and what? So is the answer 10,001? It's certainly guaranteed. but we're not sure yet. Yes. So we are not sure yet. In order to know whether that is the largest, I need to check, is there any guaranteed factors here?
11.
11. Yes. Uh, there is the test for 11. The divisibility test would certainly tell you that 11 is a factor. Is there anything else that is guaranteed? No, right? So if you want to check, very easy, right? We can just take two examples, right? So for example, I can take the easiest example is 1111. And then another easy example is 1001 because B can be zero. So two examples would be enough for me to say that, well, even just these two alone, the GCD is 11. So there's nothing else. Okay, so your answer is 11 times 10,001. Okay, so let's continue. The questions are by design very, very not equal in terms of difficulty, right? So here's what's going to happen as we move on. When there is any question that I can answer in, let's say, 2 sentences for this class, I certainly will. Okay, so if, for example, someone asks me, what is a geometric series again? I am going to answer that. A geometric series is just a bunch of numbers with a common ratio. So like let's say 1, 2, 4, 8, 16 is a geometric series. What I will not answer is, let's say, to teach you the whole topic. That's not very practical, and that's also not the purpose of this class. However, when the class size is not like what it is today, of course, I can individually tell you like, okay, you can either that you can refer to this set of notes, or you can find this website, or I can send you something to help you understand this particular topic a bit better. But for anything that you have not encountered before, yeah, that's not going to be possible for us to talk from scratch. So, geometric series has terms summing to 2026. As we just said, geometric series looks like this. So we are adding them, right? And then the sums of the squares of its terms. So it means if you were to square these, it's also equal to 2026. So what is its first term? Basically, it's asking you for A. Now, this is the typical SMO open questions that are sort of like A-level like. By A-level like, it means that there are A-level topics which would technically be also not very difficult for you, even if you're doing the SMO Junior. So that is actually where the easy SMO open questions will come from. Easy because if you are taking the A level, it's literally in your exams. If you are let's say doing SMO junior and senior, it is also already in like Olympiad questions a long time ago. So this is the sort of thing that you get that is relatively easy. And how it works is just that we have the formula for the geometric series. The formula is just a over 1 minus r. Now, as a reminder of how this works, if you have this series here and you wanted to get the sum, so let's just call it not 2026, let's just in general call it say x. The way that we reduce it down is just multiply by r, subtract it, and so x equals to a over 1 minus r. This is the geometric series formula. Same thing for this one. The first thing instead of a is now a squared. And the common ratio instead of being r is r squared. But this is still a geometric series, right? The square of terms here, this is also geometric. If you've not encountered the term before, this has nothing to do with geometry, right? The geometric series just means common ratio. Arithmetic means common difference. Nothing to do with geometry. But a bit like AMGM, the name geometric and arithmetic usually means multiplication versus addition. Okay, so now a over 1 minus r equals to 2026. A squared over 1 minus r squared equals to 2026. What do you want to do? Yeah, correct. You have to try to eliminate r. The point, I guess, is that this is a pair of simultaneous equations. Your simultaneous equations, when you have two variables and two equations, that should be enough. But of course, when they are not just linear simultaneous equations, the way in which you proceed to solve it will be more ad hoc. It varies. Here, I think the easiest way to do it is just to divide the two. Or rather, we can also say instead of calling it dividing, we can just say they are equal. Factorize the 1 minus r squared with a difference of squares. And so if you cancel off, it just means that a equals to 1 plus r. Okay, so once you have this, we can pop it back in and just solve that. So I'll do that very quickly. You end up with r is 2025 over 2027, and a is one more than that. Yeah, so for those of you who are just joining in, welcome. Don't worry about the questions that you have missed. We will send out the solutions and annotations. I'll also upload the whole video onto my YouTube channel, so you have plenty of ways in which you can catch up with whatever you may have missed. Now, there is a sudden jump in difficulty from the first three to the last three. This is by design. I am aware of it. It is not coincidental. It is not always going to be so clear cut. I mean, there are 6 questions of short questions and 4 proving ones is the ratio that I have used for the last couple of years. And I realize it works pretty well because after going through 6 questions, usually it's just nice for us to take a break somewhere around 8:20 or 8:25. And then after that, we'll go through the proving one. So it's kind of very nicely at the midpoint. Another thing about this is that it is a problem solving class. You're supposed to try it before the lesson, which means that some of you would already have had the suffering beforehand. I suspect some of you are very angry with me about this question, right? If you've tried it. Because of, well, suffering. That suffering is very important for Math Olympiads. Right now, this may sound like a bit of like boomer talk, but there is no way that you can succeed at Olympiads or anything else without like having gone through a lot of pain and suffering at some point in time. But the pain and suffering is not just a pointless rite of passage thing, right? It is that you will never ever forget the clever solutions to problems that you either spend 1 hour, 2 hours bashing through at home, or because you missed the round two cutoff by 1 point and that question was actually the reason why you missed it by 1 point. Those things you never forget. I still remember some things from my primary school that were like that. So I encourage you to get stuck basically on some of these questions, partially because when you get stuck, you understand the need for the shortcut. Okay. I'm not even going to try to draw these things to scale because for now, I will ignore the equations. I will ignore the coordinates. This question is coordinate geometry in the sense that like this part is the coordinates and this part is the geometry. Now, generally speaking, you have to make the decision of which one of them is the so-called more critical factor in a coordinate geometry question. And I think here, the coordinates, there's not much to say. You're supposed to find A and B. I can't find A and B without some help from the geometry side of things. So let's try to understand the geometry side without worrying too much about trying to draw this. I don't know A and B, I can't draw it to scale anyway. So I have 2 circles. There are 2 points P and Q. P1 equals to PP2, QQ1 equals to QQ2. These are basically the same constraint on P and Q. So I just want to understand what is this really saying. Whatever it says about P, it is also saying about Q. Now, it tells me that the tangent line from P to the first circle hits at P1, the tangent line from P to the second circle hits at P2, and the two lengths are the same. So let's say, for example, if I draw this as my tangent, and I draw this as my other tangent, I am saying that this length here and this length here are the same. Okay, what's significant about this? And I'll be honest here, there are 1/3 of you who have no chance of answering this question. Yes. So a few of you who are actually familiar will realize what is going on. which is that this tells you that if PP1 equals to PP2, means that P has equal power with respect to both circles. Which means that P lies on the radical axis. And of course, likewise, so does Q. Now, I'm only going to explain the radical axis up to a very basic level. The radical axis of two circles refers to when you have power of a point, the set of points that when you calculate the power of a point for the first circle and the second circle, they are the same. That's what equal power with respect to both circles means. Now, when the two circles intersect, this radical axis is called a radical axis because it is a line. And it is the line that passes through these two intersection points. This is the radical axis, meaning my diagram is wrong. The points on this line, and only this line, will be the ones that have equal power with respect to both circles, which means that my P actually does not belong off the line, it belongs on the line. And you will see that it should look correct. Now that, yeah, these two definitely look more equal to each other. Okay, so that's the geometry thing that is key. The key is to realize that if P and Q lie on the radical axis, that means that PQ, the line, is the radical axis. Now, once you do that, then you can go back and look at the question and realize that, oh, PQ points are given. This is 10, 14. This is -7, -3. The equation is just going to be y equals to x plus 4. It's just line equation of a straight line. And so my two circles and the equation y equals to x plus 4 are all going to intersect at these 2 points, which I shall just call them, let's say, M and N. So my idea is that M and N are the intersection of C1 and the line PQ. And then after that, use Mn, which also lie on C2, to find the A and B. So that's the plan, and now this is just an algebra task. You do not really even need to do any coordinate geometry beyond equation of a circle. Okay, so I will substitute it into C1 because C1 is an equation that I do know. Okay, I will fast forward the expansion. And you will end up with x equals to -1 or 5. which means that your M and N are -1, 3, and 5, 9 in some order. Don't care about all. Okay, and then now I substitute this into the equation of C2 to find A and B. Right, so the equation of C2, x squared minus 14x plus y squared minus ay minus b equals to 0. So the two unknowns are A and B. I have got 2 points that lie on it. If you substitute in, you will get these two. And then you can solve. So what this class, I guess, for better or for worse, the design of it is that the lessons do not have topics associated with them, right? So whenever, let's say, we have the lesson called coordinate geometry, and then after later we have a lesson, let's say, on power per point or radical axis, the name of the lesson is always a spoiler, right? SMO doesn't have like a topic associated with every question. So for those of you who have learned that topic before but haven't really applied it so much, you get random jump scares from me every few weeks. For those of you who have not learned it before, then you sort of get your first chance of hearing this name like radical axis. Now, of course, if you neither know how quad geom works nor how circle geometry works, then the question is hopeless. So that is indeed true, which is the nature of a question like this, which would be considered as a above average difficulty question from the open round one. Right, so question 3 will be like an easy question from open. This would be a harder question from open. Okay, some of you do not, like I said, do not understand what is going on here. Do not feel very obliged to copy each and every syllable and symbol down, right? Blindly copying is no use. This is on Zoom. I hope that you are not, let's say, zoning out and enjoying the fact that you do not have a handphone ban at home. But you do not need to feel obliged to understand how to solve every single question. Okay, so like mean that after the lesson, if let's say that you have something that you say this is too hard, I'm just doing SMO Junior. Why, like, yeah, I mean you should not expect to understand 100% of every solution, but you know what you need to go and check out in order to understand the solution. Right? That's good enough. Okay, so questions 5 and 6 are from the AIME. Now, as advertised for our class, we have also this aspect, I'll scroll back in a second, of seasonal problem sets. All of you are also taking different competitions at different points in time. When I am talking about seasonal problem sets, what I will be focusing on are so-called the major ones. So for example, AIME is in February. Some of you are taking the AIME, so there are AIME problems. Right? Some of you will be taking the IMC selection in March, so there will be some of that in February. Some of you are taking the APMO in March if you are in the senior or national team. So in February, we will have some of the proving questions taken from APMO and so on. So we will also cater it to whatever competition is coming up. I will also sometimes take questions from contests that literally took place 1 week ago, such that you cannot have possibly seen it before, right? I hot off the press. That's the reason why you do not have a bundle of notes coming to you for this class. Right? I will upload them week by week. Because if let's say that the AIME questions, of course, last year's ones, they are existing from a long time ago. But there are competitions that take place in January, and I can just put those questions in like right after they take place. Right? That's the reason why it does not come out to you in advance, so that I can try to make sure that all the questions you get actually look new. Okay, so let's continue on to question number 5 and 6 before we take our break. These are both AIME problems that also would not have been covered in our usual lessons, right? For the Sec 2 and Sec 3 classes, we are doing AIME problems. For the first few lessons, these are not in there. I prepare all the lesson notes, so I know they're not in there. So, question 5. There is a triangular array, which for the sake of saving you a bit of time, I have included it for you. The rule is as follows. In each square of the 11th row, a 0 or 1 is placed. And then you basically have this number pyramid. I'm sure some of you in your primary school classes, maybe even with Coco, you have seen those kind of number pyramid, right? Like you just sort of like have a pyramid and then like you just fill up the numbers, let's say, by adding sort of like a Pascal's triangle in reverse and then like just by addition. Now this one, just 0 and 1 at the bottom. So which means that if I were to give those numbers to you, it would be very easy to do. Pretty boring, but easy to do. The question is asking you how many distributions of zeros and ones will make the number in the top square a multiple of 3. Okay. So how do you... Fine, let me start. I will tell you the answer. The answer is 640. Um, Show of hands or show of Zoom responses. Who got 640? And if you did, how did you get 640?
5 times 2 to the power of 7.
5 times 2 to the power of 7. Okay, so what is 5 and what is 2 to the power of 7?
Firstly, I draw the whole Pascal triangle to the 10th row or
Okay.
11th row. Yeah.
Yes.
So it starts with 110, 45, 120, 210, 252, and so on. So,
Okay.
so the only 1 and 10 at the back and at the front will contribute the 1 there. But
Okay.
that all these rest are the multiples of 3. So no matter what I write there, the answer will still be not changed. And only 1 and 10 will be like there will be 1 left because 3 times 3 equals to 9, and there will be another 1 left. So there are 4 blanks I need to write. So I need to write 2 ways. One is leaving 4 zeros, and another is leaving 1 0 and 3 1. So there are totally 5 ways. And in the middle, there are 7 numbers that I can write 0 or 1. So there are 128 ways. So it's 128 times 5.
Okay. Yes. So that sounds perfectly right. Great. So thank you. For everyone else who has not solved it, you probably are mildly perplexed by like, okay, you kind of say, I understand that this looks a bit like Pascal's triangle, but then you're like, how exactly does this become Pascal's triangle, right? So let me explain. first of all, I'm going to sort of explain it in like the AIME context. Now, the AIME, which is the next contest that is so-called going to happen for most of you, except those of you who are taking the AMC 8, which is a small number. For everyone else who is taking the AIME, AIME is 3 hours, 15 questions, and question 13, they are roughly in order of difficulty, is considered pretty hard. Now, that means that if you can solve, let's say, this question in 15 minutes, that is pretty good. Now, therefore, if you think of it from that perspective, you may say that, fine, I am going to take a blank A4 paper. I am going to just write down A, B, C, D, E, F, G, H, I, J, K. And then after the next row, I'll write down A plus B, B plus C, C plus D, D plus E, and so on. And then after that, I will continue to go up. I shouldn't try to fill it into this box, right? That's insane. So like let's say A plus B, B plus C, C plus D, T plus E. I won't fill up the whole row, right? A plus 2B plus C, B plus 2C plus D, C plus 2D plus E, and then here A plus 3B plus 3C plus D. And then you would potentially notice the pattern, which is that A, when you say Pascal's triangle, we are referring to the coefficients, right? You suddenly magically see that this shows up. So if you write this down and you notice the pattern, then you can infer that the coefficients, let's say this one is corresponding to 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. You are basically going to just write down Pascal's triangle all the way up to that 10 for 11th row, depending on what you count as row 1. And then after that, that would allow you to fill up. And so what Chen Mo mentioned is that essentially the final result, if you wrote it in this form, is going to look like 1, then 10, 45, 120, and then after it symmetrically goes back. And because we only care about mod 3, everything else in the middle, all basically is just going to be 0 mod 3. Now, this is sort of like perfectly good in terms of verifying correctness, but you still may say that, teacher, that sounds a little bit annoying to do because, first of all, I don't feel like writing up Pascal's triangle so many rows, and second of all, like, how come it's like that? How did this happen? Okay, so there is actually a very surprising explanation for how this works, which is as follows, right? Now, when you look at the coefficients, you can think of it as they just came from below, right? Meaning that the contributions are from the stuff below. And so this one has 2B because here has B and B. And then this one will have 1B because it only came from here, and so on. The number of each variable that appears is basically from counting roots. It is the number of paths. So if let's say I ask you this thing here, there'll only be A. There's only one path from here. But if I ask you how many are there, it's actually going to be how many paths are there to get from here to here. And so the explanation, in a way, is that the coefficient of, let's say, the nth variable, if we just number them from 0 to 10, is just going to be 10 choose n. Because the number of pathways is the number of ways to arrange n moves in this direction and 10 minus n moves in this direction. That's how you get 10 choose n. And that is basically what is going on under the hood. This is how we're going to take a lot of these questions, right? I'm going to sort of tell you that, okay, fine. If you are in a competition, feel free to just do this, write it all out, just fill up one big giant table until you see a pattern. But there's also a reason why it works. You do not need to recognize how it works during the competition, but it's good to know. So this is what happens. And therefore, that is the reason because of 10 choose 2, 10 choose 3, 10 choose 4. All of these things are going to be divisible by 3, which brings us to only the ones at the front and back are left over. Okay, and then from there, the counting thing is what Chen Mo mentioned is correct, which is that your A, B, J, and K will either have all zeros, that's one way, or 0, 1, 1, 1. And then the rest of them can be 0 or 1 with no constraint. Right? And so that's how you get 5 times 2 to the power 7, which is 640 ways. When you are in the competition and you notice some pattern, if you cannot figure out why the pattern works, please don't spend too much time thinking about why. Flip side, if you are doing practice, you see a weird pattern, please do think about where it comes from. That's how you can make your round 1 practice also round 2 practice at the same time. Thinking about why. Because in round 2, it's all about the why. In round 1, it's all about the what. If you do both, you practice both at the same time. Okay, last one before we take our break is question number 6. This is probably one of the harder logarithm questions that we have seen in well, any competition for that matter. This is from the AIME 2017, and it's also one of the questions toward the back. Rather commonly, I always tell you guys that it's very difficult to set an interesting logarithm question because most of them turn out to just be using the identities quite boringly. For this one, good news is that your logarithm part is not as horrible as you think, but also it's not just about the logarithms. There's also some number theory to do in this statement here. This is not just an answer extraction. Right? Whenever the AIME asks you for the remainder when divided by 1000, AIME answers are 0 to 999. So it could be just the answer was 1064. So therefore they want you to write 64. But sometimes you actually need to do some number theory, and this is one of those cases. Okay, so let's not take too long on the standard logarithms part. For the first equation, I will first get one layer of log away by taking a to the power of both sides. Okay, so there's one layer. these two can be combined because they still have the same base, a. So by our logarithm rule, we know that product rule, and I will just move this to the other side. Okay, so I will then take a to the power of both sides again. I noticed that this is kind of interesting. It looks like it is annoyingly stacked like this, but I can also write it as a to the 128 times a to the 128. Now, at this point, I am getting a bit annoyed, so I want to know what am I doing here. I realize that the second equation has two layers of a's. So let's pause this thing because I don't know what I want to do with this, so I'm not going to just keep on working on it until I have some direction. We want to find x. X is only in the second equation. And if you just remove the two layers of a's, you realize that x is actually a to the 256. So this is not as terrible as it looks. Like, it looked like as if it's going to be a gigantic waste of time. But actually, it seems we are actually going in the right direction somehow. Because if this is what it is saying, it means that x must be an integer, right, for the question to make sense. So if x is an integer, a to the 256 is sort of quite close to a to the 128. I should keep going. I am not going to give up yet. However, there is a bit of an issue, which is that you realize that if we ask the question, how are these two related to each other? It's not that easy to answer, right? Like, it is, I mean, you can of course answer that in various correct ways, but there isn't one very simple thing relating these two. It's not just squaring. I'll figure that out later, but somehow this has to be nice, right? That's what the question implies. Okay, so what am I going to do? I am going to move the 24 inside and raise both sides to a to the power of both sides a third time. This 2 to the 24 looks like 2 to the power of 2 to the 4. That's not stacked, that's just 24. And I realize that at this point, this basically just is to the power of itself. And 2 to the power of 24 can be written as 8 to the power of 8. So because of that, I have found out everything that I can find out from equation number 1. This is basically logarithm slash indices logic complete. Now I need to somehow get from here to x. How do I do that? Well, uh, I just now said that how are these two related is not that easy to say. I think that the only thing I can think of is that this 128 and 128 add to 256. So if I write it like this, at least I can replace this thing with 8. Which means that I just need to find a to the power of 128. And to find a to the power 128, I will basically do the same trick as I did here, but with one less layer, which is raise both sides to the power of 128. And I want to make it look like the bottom and top are the same. If I borrow one factor of 2 from the top and make it 8 squared, I get 64 to the 64. So that actually tells me that my x is 8 to the power of 64. Now, there's a little bit of number theory then involved in getting what is this thing mod 1000. But for those of you who know, I think that's pretty standard. And for those of you who don't know, I think that will take a bit too long to explain Euler's theorem and all of that. Right, so I will leave that to you. I will just give you the answer. Solutions, like I said, I will upload. So I will just leave you to take whatever means that you would like of getting the last 3 digits of 8 to the power 64. Or if you have no idea how that can be done, you can refer to the solution that will be sent out after the class. Right? I think everyone's brain is probably semi-fried. So it's a good time for us to take our 5-minute break here. If you have any questions about the logistics of the class, feel free to ask. If you have been pretty lost about what we have just done for the last 20 minutes, please don't leave because the first proving question is usually going to be much easier than the last short answer question. It's not going to just get harder and harder for the whole lesson. Okay, so yeah, we will take a break here, but if you have any questions, just let me know. And if you need to go to the washroom, stretch a bit, get a snack, then please do that as well. Okay, so some general questions, I guess. Firstly, is that what if I get stuck? If you get stuck during the week, you don't have to submit homework every time, right? So it's fine to just stay as being stuck, and then wait until the lesson for me to go through it. But if let's say that you just feel very curious about this problem, you want to know a solution, sorry, you want to get a solution yourself, you can ask for a hint. I will just respond to you with some hint, depending on just let me know where you're stuck. Are these lessons every week? Yes. I mean, this is a course. This is not just a one-off lesson, right? This is a course. It has the same 18 weeks of classes as the usual Coco lessons. So there are problem sets every week. Some of the problem sets will be not exactly like this. For example, I will sometimes have some special, uh, no spoilers, right? Some special set. So previously, let's say I did a National Day set where all the questions are themed on Singapore. I have done, let's say, a Chinese New Year set where it is themed on the zodiac animal. Like, I mean, I will have some interesting stuff. I had, let's say, a problem set that was relating to elections before our Singapore election. So I will use this class as a time where, like, if there's just anything cool that I want to do that is relevant, we can do that too. But most of them will look like that. Because at the end of the day, we are preparing for competitions. So rather than, let's say that this class is preparing only for the SMO, we are learning math because different competitions do require different types of math. For proofs, if you are familiar with how proofs work, or rather, if you are very familiar with how proofs work, you generally will know whether your solution is valid. Right? Meaning that you will know when you solve the question, you will know when you're stuck. But if let's say you are less experienced, or for some harder questions, you have some sort of solution where you are just not sure whether it is actually a valid proof. You can send it to me not just during the last week of the month. You can just ask me, is this actually correct? Can I do that? And of course, I will do my best to give you hints if you are wrong, or just tell you are correct if your solution is. How hard is this class compared to our usual lesson? That depends on what level your usual lesson is. But this class is sort of spread across everything, which means that some of you have been here for more than 1 year. You will realize 1 year later, the difficulty of the worksheet on average has not changed. But you will find that you can do more questions on average. That should happen after 1 year. Okay, so for the first session, I have chosen to make the proving questions at least have one uh, shorter and more approachable one. Right, so the first one is relatively straightforward. Determine all non-empty finite sets X of real numbers such that for any element A in X, A plus the absolute value of A is also in X. Now, most of the proving questions are such that the answer being correct does not mean that your entire logic is fine. However, I think for this question, if you have the correct answer, most likely your logic is fine. So I'm going to go through it. And part of the reason for this is just that I want everyone who has less proving experience to know proofs are not scary, right? They're not going to eat you. Proofs are just basically making sure that everything you write down has an obvious reason for being correct. Either it is correct because of a math theorem, it is correct because of what the question tells you, it is correct because I did this calculation, it is correct because of the logic I did earlier in my working, as long as everything is logically correct, you are fine. It is not like oh, they must be written in some way. There's no 表达分, okay? There's no like grammar, spelling, and it's not about how elegant your solution is. You can give me a horrible solution that is logically correct. You get a perfect score for both your school exam as well as the SMO. So, what would be your answer to question one for those of you who tried it? You can just have zero, yes. So just the single number zero. That's fine. Is that all? Yep. That is indeed not all. You can also have negative numbers. So these kinds of questions are problems where you need to experiment, except that the experiment ends pretty quickly. This is in the style of the SMO Junior Round 2. There will at least be one question where it looks very scary, but if you just try to experiment, you realize, no, it's actually quite obvious. So yeah, some of you have the correct answer. I'll review the answer at the end, but let's just very quickly sort of experiment. Let's say that I have the number 1. Now, 1 is in there, means 1 plus the absolute value of 1. So 2 is there. Now, if 2 is there, then 2 plus absolute value of 2 is 4, and then 8, and then that already fails, right? It's supposed to be finite. So the immediate realization you have is that you can't have anything positive. So I would encourage you that for most of these proofs, if you're new, sort of keep your rough work experimentation and your conclusion separate, like your actual proof, right? When you do your science practical, right, you don't submit your worksheet together with the test tube, right? You just submit your findings. But that doesn't mean you don't have to do the experiment. So you experiment, you realize that, oh, okay, I realized that, oh, this is the issue, and it's not just one. So, so my first claim is that X has no positive numbers. And so the proof of that claim, if let's say n is in X for n positive, then 2n, 4n, 8n, etc. are all in X, which means that X is infinite. Contradiction. Okay, so that's the first thing. Now, positive or fail. Okay, so I can only have 0 and negative. Now, let's try. If 0 is there, no problem, right? It's just 0 tells you 0 should be there. Now, if let's say minus 1 is there, minus 1 plus 1 is 0. Then you realize actually all the negative numbers just need 0 to be there. So my conclusion just turns out to be that well, 0 must be in the set X. Because otherwise, X must contain some negative number. And then A plus the absolute value of A is 0. It's in X anyway. So that's a contradiction. So you still have 0 in X. You also realize there's nothing else we can say. So the answer is literally just any set that contains 0 and no positive numbers. So when I say any set containing 0, it can be 0 and all negative numbers. It can be 0 and all negative integers. It can be 0 and just nothing else. It can be 0 and the number negative 1005. Those are all fine. So we just answer the question. We're done. And of course, the question said finite, right? So I should also say finite for this case. So no, I cannot actually grab all the negative numbers. Yes, because it is a finite set. Now, these kind of questions really are not harder than round one questions, right? It's just that it is more abstract and you need to write something down. But they are fun and they are not more scary. Now, there are also the questions that are for proofs that are not actually more abstract. It's just that the question is in the yes or no form and explain why. So it's like your science exams when you ask you, please explain why this happens. Like, why do you see bubbles when you do this thing? You don't say that's too hard. No, I mean, explaining is fine. We can explain stuff. Okay, so very quickly, again, I am going to do a quick question, A, B, and C. Which ones are yes, which ones are no? Okay, you see, right? Yeah, some of you have the correct answers. If you have the correct answers, I hope you also know why. When the question asks you, do they exist? For proving, you do not need to explain how did you get the answer if the answer is yes. Now, this is different from school, right? If let's say that in school, you have a question, they expect you to show how you got the answer. I don't need you to show me how you got the answer. I only need you to show me how do you know your yes or no answer is correct. So basically, demonstrate to me you are right. I don't care how you came up with the idea. Just like when you write an essay, right? You don't need to tell the teacher, how did I think of writing this on this subject? No, you just need to make sure the subject that you've written, you write about it properly according to the requirements. So for example, in part A, the answer is just yes. The smallest example is this. This works. So Mn can be 3, 3. Now, I am not claiming that 3, 3 is the only way. So maybe some of you tried this, you got to answer yes using some other combination. That's fine. I didn't ask you, give me all possible Mn. How do you get this? Guess and check. Because we don't know whether the answer is yes or no, right? So like when we don't know if the answer is yes or no, I mean, what will you do? You just write down some powers of 2. You write down some powers of 3. And then you just try to combine, see whether I can take 2 of them, put them together, and then plus 1, and then get exactly a square number. I'm not saying that 8 plus 27 plus 1 is the only way, but it's the smallest one that I can find. So that's the first one I write down. Then the follow-up question is that I'm going to tell you that part B is no. How much effort do we need to put in until we can say that it's probably no? That is very hard to say. But as you are experimenting, try to see, let's say, why am I getting stuck? You don't need to give all the reasons why you got stuck. You only need to give one reason why we are stuck. So let's say that, okay, for this part B, it's just powers of 3, right? This is my list here. I am going to try to look around. Let's say I take 3 plus 9 plus 1 is 13. 3 plus 27 plus 1 is 31. 9 plus 27 plus 1 is 37. Now, you are also allowed to, let's say, have repeated the same thing. 27 plus 27 plus 1 is 55. So you try and then you fail. You will not be able to find one. And so we will try to look for a reason. And the reason usually for no is using some modular arithmetic filters. Now, for those of you who got no, what mod did you use in order to confirm it is no?
Or I don't know. I didn't do.
Okay. For those of you who did, what mod would we use? Yeah, mod 8. Yes, I think mod 8 is the smallest one. Now, the idea is that for every mod that we pick, we know that there are only a limited list of possibilities. For what a square is, I want to make sure that my mod also has a limited number of possibilities for what powers of 3 can be. I can't take mod 3 because it will just tell me the number is 1 mod 3, and 1 mod 3 may be a square, may not be a square. Right? 1 is a square number, so it is possible. One way that I can make sure that it is restrictive is to pick a mod where as soon as possible you reach 1, meaning that the cycle repeats as soon as possible. And if I pick mod 8, then I know that it just loops between 1 and 3. And so therefore, if you add them with a plus 1, it can be 3, 5, or 7 mod 8. But we know that squares, specifically odd squares, are 1 mod 8. Clearly this is odd. If you don't say odd squares, squares are 0, 1, or 4 mod 8. So this means this cannot be a square. Now, same logic for part C. If you try it for a while, you will realize that you can't seem to make it work. And indeed, we'll just pull out another mod. What mod can we use for part C? No, we can't quite use mod 8 again. We can't quite use mod 8 again because if this is 0, and then this is 3 mod 8, 3 plus 1 is 4 mod 8. 4 mod 8 can be a square. 4 is a square number. So that does not reject the possibility. Yes, mod 3. Just use mod 3. Right? Mod 3 is straightforward enough because power of 3 will disappear. Power of 4 is just going to be 1. Right, so you add it. You get 2 mod 3. And we know that squares are going to be only 0 or 1 mod 3. This is the usual way that we show that things cannot be a square, cannot be a cube, cannot be a power. It's one of the usual ways. There are other ways, but we will see that as our class goes on. Modular arithmetic is the most common way of showing that an equation in integers has no solution. Okay, so let us continue. Now, the last two questions are definitely harder. So the first two can be said to be like junior round 2 in style. The last two are definitely senior to open round 2 in difficulty. I'll talk a bit more about diagram drawing also as our lessons go on, but I think that we are a little bit short of time. So I am going to just put in my prepared diagram and explain what's going on. So this is my prepared diagram. Now your diagram does not need to look identical to this. Specifically, I added in the few points here, which I will explain what they are doing there in a second. But everything else is given. So you have got a triangle, you have a circumcircle, you have a tangent line, right? So to be clear, the tangent line AT is tangent, means that this is 90 degrees. H and O are the orthocenter and the circumcenter respectively. CH passes through the midpoint of AT. So this is just what I call X. Show that AO bisects CH. So bisects means chops it into two. It makes perfect sense that I will give that a name. And so let's not like beat around the bush. What I did in order to construct P is just to reflect C over X. Now, you may ask why I would do a reflection of C over X. And the answer is very simple. One of the ways that we use midpoints is to form a parallelogram. So if you have one midpoint and you reflect something over it, you get a parallelogram because now I have got two midpoints. Why did I choose to reflect that one? Well, I'm not actually only interested in reflecting C. I just basically want to extend it out because all the action is on this line, right? Your X, your H, your Y, your C are all important points. Is this the only way to solve the question? Most certainly not. So when we are doing geometry questions, especially, I always say that construct one extra point or one extra line. There must be at least one obvious benefit, which here is parallelogram. And there must be one like surprising benefit, which whenever we try a construction, it's called surprising benefit. We don't know yet. We just say that, I think maybe this would be nice. You try it, and if nothing good happens, you try something else. If something good happens, that's probably the one that you want to use. Okay, so let me just write down clearly that we want hy equals to yc. Now, when you are doing the harder questions for our class, I will focus less on the writing of the solution and more on the just problem solving, as the name suggests. So I often won't write the full solution down line by line. I will just generally talk about the stuff that we do, and I'll leave you to read the solution if you want to see how could I submit this to the competition. So it is, first of all, a good idea to do a little bit of angle tracing. The special thing about T is that AT is perpendicular. I haven't used P yet because like I'm just explaining what the diagram is, but we'll use that later. The special thing is that we have a perpendicular. I do know a lot about angles pertaining to the orthocenter and the circumcenter. Right, so I can angle trace anything I would potentially want, and one of the typical things that we will do is that we can say these angles are equal because H and O are isogonal conjugates, meaning that when you draw this line from A to H and A to O, these two are both equal, and you can check they're both equal to 90 minus B. But I'm looking not just at that, I'm just trying to look for some way of involving similar triangles somewhere. Oftentimes when we do similar triangles, we don't have to have made up our mind where exactly they are, but just in what rough vicinity they are. Okay, so what I labeled just now, if I give it a name so it's easier, I'll just call it theta and theta here. The important thing is that this is 90 degrees because H is the orthocenter. So this is 90 plus theta. And if this is 90 plus theta, this is also 90 plus theta. So I do get similar triangles AHC and XAC. Now, you can imagine why that would be somewhat important. You wouldn't know why that does all the work for you. But you can imagine why that is important because it is now relating a little bit to, let's say, the length of HC, which is related to what we want to find. I also need to do some stuff with Y because Y currently is just a random intersection between AO and this long line over here. So this is where I, again, want to do a little bit of angle tracing. I mean, there are a lot of equal angles that are hanging around all over the place. But what happens is that I basically want to make this AYC triangle do something. That's actually why I extended this in the first place. I extended in the first place because this would allow me to get a pretty big similar triangles. AYC is similar, you see this theta and double marked angle to CTP. CTP though, because this is a parallelogram, I'm not really interested in this bottom half. I will just shift it back to PAC. Okay, now between this equation And this equation, I kind of can see that there are a lot of overlapping points. I can see that CH is here and CY is here. There's no HY, but I basically want HC to be twice of YC. So I will write down what the corresponding lengths are for both, and then hopefully it works out. So the first one will tell me that HC to AC is equal to, let's go for something that appears in the other one. So no more H's because H doesn't appear in the other one. HC to AC, I will use AC to XC. And for the other one, YC to AC is equal to AC to PC. Yeah, so it's pretty clear that this gives us what we want because that means that PC is twice of XC. That's what I have defined it as. So Y is the midpoint of HC. If you came to the lesson without having tried the question, this is not a scolding or a reprimand. This is just a pretty unsurprising thing because we only sent the questions a few days ago. This seems pretty mysterious. It's like where you consider that particular random angle, random length, random stuff. This is why you try the questions, right? So if you have tried the questions, it usually would mean that you can understand where is the point where you get stuck and why is it that, let's say, what I did makes sense. And if you think you have a better solution, then of course you can share, we can discuss which one would be more obvious or which one would be more efficient. This applies to question here. It also applies to the last question, which I will also not write down a full proof. I am just going to sort of give the rough intuition, and then you can just try it for yourself to finish the proof. Okay, so question here says that each positive integer is colored in one of three colors: red, green, or blue. Now, I define these three functions, Rn, Gn, and Bn, to be how many of those factors of n are red, green, or blue. And then I define two more functions, xn and yn, to be the maximum and minimum value among these three. So basically, which color appears the most, how many times that goes into x, which color appears the least, how many times is that that goes into y. Does there exist a coloring such that xn minus yn is at most 1 for all positive integers n? Basically, this can be taken to mean that the factor colors are so-called as balanced as possible, right? Because if let's say there are three factors, you want one of each. If there are four factors, you want two, one, one. If there are five factors, you want two, two, one. So that is basically the question. I want to come out with a coloring or show that it is impossible to come out with a coloring such that the factor colors are balanced. Okay, quick poll. Do we think the answer is yes or no? Okay, I see a lot of no's, right? This sounds a bit too good to be true, right? I think no is a perfectly good guess. So when we do something like this, I think that whether you believe the answer is yes or no, you should, again, same word, experiment. You should experiment. And what I mean by experiment is that in my mind, if the answer is yes, how on earth is that possible? I better experiment enough so that I can even come up with a guess for how to do the coloring. Now, if the answer is no, that's not so surprising, maybe. I think that I can probably just find some sort of place where I say that, oh, this thing can neither be red, green, nor blue contradiction, like some sort of like Sudoku-like logic. So let's just try. Okay, now I am going to sort of start off with a number with 3 factors, because if the number has like 1 factor, I have nothing to say. If the number has 2 factors, then they must be just 1 and itself. Actually, wait, that's kind of interesting. Maybe we can think of 2 factors. So let's say that 1 is red. It doesn't matter what the first color is. So let's say 1 is red. Then what do we immediately know about the prime numbers? They're not red, yes. So the primes are not red. Doesn't matter whether they're green or blue. So let's say I said the primes green. So all the whole group of primes blah blah blah. Right? So all the prime numbers cannot be the same color. It doesn't matter whether it's green or blue because we haven't really distinguished those two yet. Okay, now I want to look at those numbers with 3 factors. Because if they have 3 factors, it must be 1 of each. What kind of numbers have 3 factors? Correct? Prime number squared. Where do the prime squared go to? They are blue. Yes. Right? The prime squared, let's say 4. The factors are 1, 2, and 4. Okay, so this is sort of okay, a starting point. Like this is forced. Now, if let's say that I consider the numbers with 4 factors, 4 factors can be in 2 ways, right? The cube of a prime. The cube of a prime, I have no idea where it goes. I cannot tell, but there's no contradiction because there's already 1 red, 1 green, 1 blue. So then it can be anything. I don't want to talk about something I don't know. There is also another type of 4 factors, which is PQ, 2 primes multiplied together. So if I have PQ, it means that there is already 1 that is red. There's P and Q, which are green. So PQ, any product of 2 primes must be blue. So all of these must be blue. Now this is starting to get interesting. The next one I'll think about, I don't want to consider powers of a prime anymore because I'm a little bit It still doesn't tell me anything yet. Let's think about p squared q. Now, for p squared q, 1pq and pq are also factors. P squared is blue. So that means that p squared q is forced to be red. And then you realize the disturbing thing is that we are not hitting a contradiction. In fact, not only are we not hitting a contradiction, if let's say we consider one more, which is let's say 3 primes, we'll end in a couple of minutes. Now, this is red. These are all green. These are all blue, which means that this is also forced to be red. It seems that we have accidentally actually found, to a large extent, a conjecture for how the coloring can be done. It turns out the answer is yes. This is 0 prime factors. This is 1 prime. These are both 2 primes. These are both 3 primes, and so on. Now, the thing about this is that you may ask, but how do you know that the pattern will continue? The question is, does that exist? You do not need to prove the pattern continues. You only need to show that this works. You don't need to show this is the only way to do it. Maybe it is, maybe it's not, but check it because it seems to be working pretty well so far. So it turns out that this is actually going to work. So for any number with prime factorization, right? So just let the sum of these exponents, meaning how many primes, let's say call this equal to n. Just color the number red, green, or blue if n is congruent to 0, 1, or 2 mod 3 respectively. And the kicker, I guess, is that if let's say this question were a SMO problem and you flip to the back of the solution book, I don't know if you still buy the solution book if you watch my YouTube videos, but if you buy the solution book, the first line of the solution will be, yes, basically it starts here. And you will think, who on earth is going to come out with this sort of absurd idea? Because the solution does not show you this. This is why you come for a class. I basically peek behind the curtain where the constructions come from. It's like a puzzle. And personally, I like these kinds of questions where it is reasonable. There are ideas that are not reasonable. No one in Singapore solves a question in SMO sometimes. That's just a bad question, too hard. But there are questions that if you are willing to dig and experiment, that's why you get 4 hours or 5 questions. Okay, so I will leave you to try the proof of that this thing actually works. This is not the full solution, but this is the key step. Realizing the answer is yes is the key step. So I've shown you why you would think it's yes and why you would think of this. Proving the rest of it is just by induction. A bit annoying, but not terribly hard. Okay, so we will end the lesson here for today. This is a trial session. We will send out all the materials. For those of you who have already signed up, the solution, the recording will be up tomorrow on the course page. If you have any issue finding it, let me know. For the rest of you, you have a bit of time. You can think about whether this class is at that correct level where it's not too easy or too hard. And if you have any questions, just let me know or ask your parents to check with me. Okay, so Happy New Year. I guess your brain has been given a thorough workout. So have a good night's rest. And for those of you who do continue, I will see you next Wednesday. If you are in the rest of my classes, I will see you later in the week. So bye-bye. Hope you had fun.